Dear colleagues, ladies and gentlemen, in my short video presentation I would like to show you some developments in the newest version of Wolfram Mathematica. When you open the Mathematica, new design, new user interface, menus, modern color schemes you can find. But the most important development by the Wolfram research is the own AI development, the AI service, the notebook assistant and large language modeling kit. For both intuitive and professional users, you can meet with new and improved mathematical functions, differential equations and algebra and integrals, for example, symbolic arrays and operations with undefined dimension is the very new development now. New functions for structural programming, operator for new data types, help your Mathematica programming. New functions for other fields, chemistry, biology, physics, geography and more. And new fields are implemented, for example, the game theory. And of course, in other technical fields, technical tools, new functions for others, for example, image, video, sound, and so on. And there are many more you can find. I summarized the new features in the recent developments in this table, in which the descriptions of the improved features on the Wolfram website and the Stephen Wolfram's nice introductions can be found. But now let me consider some of the most important possibilities now. Look at the intuitive work with Mathematica. AI, LLM, chat-based statement. In former versions, of course, you remember and you know very much that free text input evaluation using Wolfram Alpha was introduced. I don't know in which version, many years ago. For example, if you would like to plot the functions, just plot x squared or ask anything, this free text command is transferred to Wolfram Alpha, evaluated, and then the output is given back to Mathematica. You can convert the free text input to the Mathematica syntax, also using the Wolfram Alpha. Now what is new that the language level support for control equal, actually the Wolfram Alpha input is implemented in version 14.1. But what is really new that since version 13, different AI services are involved in Mathematica. For example, one of them is the Together AI. Connecting the service, you can use LLM synthesize, image synthesize, or other statements using these external AI services, and so on. Some of them don't work, but the reason is simply that you need some fee for that, some subscription. Now chat cells, chat notebooks were introduced in Mathematica in version 13.3. For example, the simple question, what is the tallest mountain in Hungary, using the Together AI service was added, and the long answer was given by this service. But now the newest service is the Notebook Assistant that was introduced in 14.1 and now improved in 14.2. This service is available with a monthly subscription, but in this case no other external AI service subscription is needed. I would like to mention that many nice examples are given on the Wolfram website and in the video presentation of Stephen Wolfram. But now let me show you some examples from my practice. Plot me, for example, the cobweb and bifurcation diagrams for the logistic mapping, changing the parameter dynamically in the cobweb diagram. That's the Notebook Assistant answer, very nice and correct answer, and it can be pasted and inserted in my notebook, so without any change I can use this code in my development, in my research. Now let me consider another question. For example, how to plot the trajectories of the differential equation of the damped physical pendulum in the phase space. Instead of the notebook assistant, I use here a chat input statement. The answer was given, and running it without any change, I obtain a very nice figure for the trajectories of the system, and the damping coefficient is changed dynamically, and in that case, a new statement I obtained, and now it works pretty well. Of course, maybe I need to run it first. Now, have a look at it, and it's really impressive and pretty. Some examples in which the notebook assistant answer is sometimes problematic. For example, if I would like to draw a carp, a fish in the style of Picasso, it doesn't give me answer. It says that I need subscription. This statement, on the other hand, in a program level, using the image synthesize statement, it works correctly. I don't know the reason, but it's a very nice feature also. And now let me consider something more. Plot a 3D map of the 5-kilometer neighborhood of the Mont Blanc. Now, in geographical questions, the results are sometimes problematic. The results of the statements, the codes are not completely correct. I needed to ask more questions to specify better statements, but at the end I received correct answer with the correct figure. Let's go on. Look at some programming new features. About calculus, in version 13 and 14.2, new functions, symbolic arrays, new forms of integrals are introduced, and more types of regions are implemented in Mathematica, what is really important in calculus and other fields of higher dimensions. If you remember, in former versions, the integral plot statements worked with symbolic regions. If I wanted to plot these two functions, 1 and 0, when x and xy vector is an element of the unit disk, then the plot can be done, and also the integral of the function can be calculated. Okay, this is the same as a Boolean characteristic function of the region is integrated. Now the line integrate and surface integrate and the complex contour integrate was introduced in version 13.3, and in the new versions, in versions 14.0 and 2, the numerical line integrate, surface integrate and contour integrates are introduced. Let me consider a two-dimensional example. Let me just simply consider the physical oscillator equation. That's the right-hand side of the equation, and let me solve the system from an initial value, and then I would like to calculate the change of the energy function along this trajectory. To do that, I need to create a parametric region. That's also a new function. I plot the oscillator vector field and the region instead of just using the parametric plot of the trajectory, and I obtain this. Now the energy function, as we know from the theory, is simple. There's the kinetic energy and that's the potential energy, and then because the gradient is negative, we know that the energy must decrease. Calculating the gradient of the energy along the trajectory, I obtain a negative value. This is the decrement of the energy from the starting time to the end time of this trajectory. Anyway, we know that if we substitute the trajectory into the energy, calculating directly the change, I obtain the same value. There are many more possibilities about the line integral. I'd like to just mention that symbolic arrays can be used in the integral. I will speak about the symbolic arrays some minutes later. Now something new that says new special functions are introduced. For example, the trigonometric functions with degree argument. It makes much easier sometimes the research and the work of the high school mathematics. Go on. The symbolic arrays, the vectors and matrices are introduced in the version 14. Formerly what we knew that Mathematica could define arrays with fixed dimension, and the norm and other things could be calculated easily symbolically. For the Mathematica developers, it's very important anyway that the symbolic work is implemented in Mathematica. That means what you write on the paper, that more or less a code in Mathematica. Now we can use symbolic variables and operations with symbolic arrays with undefined dimension. For example, x now means a vector symbol with n dimension and real values. The gradient of this vector can be calculated, and then it means that this works. And then I can substitute particular dimensions, for example, a 3-dimensional vector instead of x, or 4-dimensional. So this is really a dimension-free development. Okay, now I can also use equations with the symbolic vectors. If we define equations, the dimension must be specified for the vectors, and in that case the solve statement works correctly. Also symbolic matrices can be used, and what is interesting for me, I can simply calculate m times m to negative 1, where m belongs to the n by n matrices. It also means that the symbolic computations are important and can be used in Mathematica. Now the next field is what is important for me, because I am an ODE guy, the differential equations. Many important developments are done in the versions 14. That means, for example, the stability analysis of the differential and differential equations are implemented directly. Mainly the method, certainly the linearization method to find stability domains, but sometimes it's not true, sometimes it's more general than just the linearization method. Sometimes stability is understood as an asymptotic stability. You have to be careful with the answers, but the statements are pretty useful for you. Let me consider some examples. If I would like to consider the stability conditions using the d-stability conditions for this differential equation, we know that all solutions are constants. That's found by Mathematica, and they are said that they are stable. They are really stable, but not asymptotically stable. For the standard one-dimensional linear equation, it's also done. We know very well that the real part of a, the coefficient, must be negative. That means asymptotic stability. If a is 0, it means just the stability. The problem for me that if I change the first power of p to the third power of p, it says that the 0 solution is always asymptotically stable. That's problematic. The situation now is the same as for the linear, so a, the real part of a, must be negative. And so on. There are many other examples for more complicated equations. For example, for this linear system, the result for asymptotic stability is pretty correct. Now let me consider a real practice example. That's a system of competition of two species. Now that's the result given by the Mathematica statement. On the right hand side you can see the stream, the equilibria, and on the left hand side you can see the parameter space visualizing the stability regions of the equilibria. Something new again for about differential equations is that some equations can be solved without independent variable for some theoretical issues, for some theoretical calculations. Next field I would like to show you just an example about the applications of Mathematica concerning other fields. We know that geometric computation is very important field in Wolfram Mathematics. This is applied, these features are applied in molecule structures and computations in version 14. The molecule mesh can be calculated, can be drawn in Mathematica and giving a boundary mesh region object. Next, I would like to go to the programming in Mathematica. Tabular is a new data type. It was introduced in 14.2. It is a new column-based database using large data and handling missing data, conditional statements, export, import, etc. And the most of the list operations support the tabular. Look at a simple example, the European countries, look at the population area and so on, import it into a tabular data structure, and I can find the special elements of this tabular, and I can also use list plot and other things, statistical statements also work with the tabular. Now go to the deep programming in the functional and structural programming in Mathematica. Nest, for example, can be an operator of the initial value. What does it mean? If I said that nest, the function f, the initial value is x, do it 4 times, I obtained this. If I just remove the initial value, nest f4 means use the nest statement 4 times for the function f, and then I can change the initial value. Many other functions have operator form, what is very important working in function spaces. The pattern-based programming is a very useful tool in Wolfram Mathematica. New statements help the pattern-based programming. That's all same by all match, on any match or non-match are new statements helping this work. Again, going back to the function spaces, the COMAP and COMAP apply statements work on lists of functions, applying them to the same arguments. And these functions are the counterpart of the map and map applies and apply statements. And there are many more in version 14.1. For example, the fail-safe statement that helps to handle the result of functions if the result is failing, and we can discard elements of a list and so on. These are just examples. Now, parallel and GPU programming is useful, knowing that most of the users have computers with many kernels and special GPUs, graphical programming units. Parallel select, parallel cases, and parallel table updated, and the parallel select and cases are new. They help the programming if we will work with large arrays, large data sets. And similarly, you can define arrays in the GPU, which is much faster and gives a new inner memory possibility for your work. Telling the truth that for small data sets, the parallel and the GPU features are a little bit slower than the standard, because the new kernels and the GPU must be initialized. But for large data sets, they are definitely faster and better than the standard. Okay, there are many more possibilities. In geometry, new regions are introduced. The geometrical computation is much more effective than before. PDE modeling is continuously developed in the last versions. Different kind of models with partial differential equations are implemented and described in Mathematica. and many more functions support the date and time. What is very new now in version 14.2 is that the game theory is implemented in Mathematica. Here, matrix and tree games are implemented. In algebra, mainly the matrices, the structured matrices, structured arrays, and interval matrices are introduced and improved. It is very important because the calculations with 1,000 by 1,000 matrix may be very, very long, provided it's not structured. Finite fields are improved and handled in the new versions also in Mathematica, so I can call the attention of the algebraists to do many more new things with Mathematica. The visualization statements are always improved from version to version. New color schemes, new features, new options are introduced, and now new statements also are introduced, pairwise plots, and the statements, the visualization statements now support the new data types as well. Similarly to the partial differential equations, the graphs and networks are also continuously developed and improved. New graph types, new graph statements are implemented in Mathematica. What is important for me, the video, image and audio computation contains new features. And finally, I mentioned that importing and exporting now is developed. New data types are supported in the import and export statements. I guess that's it. Hopefully I helped you in using the new versions of Mathematica, and I hope that you will work with the AI services developed by Wolfram Research. Thank you very much.